Good morning, everyone. Let us start something new today. And we are going to study a very interesting topic. We are going to study something which we experience every moment, every minute, every hour, every day in our lives. So, this is something which a child experiences in his entire life, a person experiences in his entire life. Even a person who is dead experiences it. So, what it is? It is nothing but gravitation. So, what actually gravitation is? So, we'll later discuss the technical details of gravitation, but before that, we will discuss the basic difference between two usually commonly used words, and that is mass and weight. So, what is mass? I'll give you an example. This particular object has a mass of, say, for example, 200 grams. So, this particular object will have the same mass if it is measured in the entire solar system, if it is measured on any planet. So, the mass remains the same because mass is matter contained in the object. It refers to the number of particles present in the object. So, it basically remains the same. Even if this particular object is moved away from our solar system, mass remains the same. But what is weight? Weight is the force exerted by the earth on this object. So what is that force? That force is known as gravitational force. And what it is? Earth attracts every object towards it. So let us consider this object. So if I am holding it this way and I am letting it go, it goes down. Isn't it? So why does this particular object go down? This was the question which was encountered by a very famous scientist, and he was none other than Newton. He was sitting below an apple tree, and at that particular moment an apple fell down. So he started thinking why this particular apple came down. It might have gone to the left, it might have gone to the right, it might have gone upwards, but that doesn't happen. What is the reason? Why this particular apple or why any other object comes down? So finally, when he tried to find out the answer, he came out with a conclusion and a discovery, and that was gravitation. So what gravitation is? Earth basically attracts every object towards it, and that is the reason why every object goes down. This is how it goes down. Fine. Let us now consider a very simple example of gravitation. So basically this is a toy weighing, say, for example, 100 grams, and this is something heavier. For example, it weighs 300 grams. So these are the two different objects. Now my question is, if I'm holding these two objects on the same level and if I'm letting it go down, which object comes first or which object will reach the ground first? So let me know your answer, and your answer will be very important. So let us consider an example and take an experiment. So this is heavier, this is lighter. So which object goes down and which object reaches the surface of the earth faster? So let's start with the experiment. Look at it, find it yourself, and then we'll discuss the result. Is that okay, everyone? Fine. So I'm starting it. 3, 2, 1. So maybe you are not able to visualize these two objects over here in this video, but I have visualized it and I have witnessed it, and you can try it for any two objects in your home, that these two objects reach exactly at the same time. Why is it so? What is the reason? We'll discuss it. So the first and foremost thing is force. Is mass into acceleration. Now, let us say that the acceleration is, say, for example, 10. Normally, we take it 9.8, but just for the sake of convenience, right now we are taking 10 over here. So, this acceleration remains the same. If the mass is, say, 10 kg, force is 100 Newton. If the mass is, say, 20 kg, force is 200 Newton. but this particular value remains the same. So, if the mass is different, force exerted by the object, rather force exerted by the earth on the object is different, and it goes proportionally. If this increases, this also increases, which keeps this constant. So basically, acceleration remains the same even if the mass of different objects are different. So that is the reason why two objects fall down at the same time. Now we started with basic concept of mass and weight. So what is mass? Matter contained in the object. What is weight? It is the force applied by the earth on that object. That is weight. So weight will differ on different planets. If you weigh yourself over here on earth, for example, you may be 100 kgs, for example, or 50 kg, for example. So your weight over here on earth is 50 kg into 10, basically 500 Newton. But similarly, if you weigh yourself on moon, you'll weigh 6 times less, and your weight will be 500 Newton divided by 6. So isn't it amazing? For example, if you weigh yourself on any other planet, so the gravitation or the acceleration due to gravity on that particular planet will be different, and you will weigh something else. So you can fly, you can walk, you can hop, you can have different activities of sports on different planets, isn't it? So isn't it very interesting and amazing? So let us talk about the technical formula of gravitation, and that is nothing but Newton's law of gravitation. So what basically Newton wanted to say about gravitation? So he said that every object in the universe, not only Earth and different objects, every object. So is this object included in every object? Yes, this is included. Am I included in every object? Yes, I am included. So these two objects, for example, this and myself, every object or every body in the universe will attract. So I can write, will attract with a force, which is directly proportional to m1, m2, product of their masses, and inversely proportional to the square of distance between their centers. So I'll draw a diagram over here representing one object whose mass is say m1, the other object whose mass is say m2. Distance between their centers is say r. So what will be the force? Force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So usually what we do is, when we are trying to remove this sign of proportionality, what do? We introduce a concept of proportionality, and that is F is equal to capital G, which is nothing but constant of proportionality, M1 M2 divided by R square. So what is this G? This is something which is constant in our entire universe. So what is that G? That G will be equal to the force exerted by two objects of unit masses each and separated by a distance of 1 meter. I'll explain you once again. Let us consider two objects whose masses are 1 kg each, which are separated by a distance of 1 meter. These two objects will exert some kind of force, some magnitude of force, and that magnitude is nothing but this capital G. Isn't it very simple? Let us now talk about small g. What is the small g? It is nothing but acceleration due to gravity. Now, what basically acceleration means? Acceleration is rate of change of velocity. For example, I am driving a bike, I am driving a car. At the 0th second, my velocity was 0 meter per second. After 1 second, my velocity became 10 meter per second. After 2 seconds, it became 20 meter per second. After 3 seconds, it became 30 meter per second. So I can say that my velocity is increasing at the rate of 10 every second. So in that case, I can say that the acceleration is 10. Similarly, this is acceleration due to gravity, which means that if you hold an object at a particular height, say for example on the top of Burj Khalifa, you are standing and you are holding an object, and the moment you release it, what happens is, at the 0th second, the velocity will be 0 meter per second. After 1 second, you will find that the velocity has gone to 9.8 meter per second. After 2 seconds, you'll find that the velocity has gone to 19.6 meter per second. After 3 seconds, you'll find that the velocity has gone to 29.4 meter per second. So you will find that each and every second the velocity is increasing by a number which is 9.8. And that 9.8 is actually nothing but acceleration due to gravity. So with this, we complete our topic today. Isn't it very simple? It is. And it's really amazing, and we experience it in our day-to-day lives. So friends, enough for today. Bye-bye everyone.